Hello students, welcome to this session of synthetic fibers and plastics. In this session we are going to discuss about plastics. See, plastics are synthetic polymers, right? These are, we can say, the polymers. Polymer is what? Poly means many, mer means units. So many single units they combine or they join to form polymers. We'll be discussing about plastics here, the types of plastics, right, on the basis of their linking, on the basis of linking of monomer units, or on the basis of linking of polymers. There are different types of plastics. So we'll be discussing about different types of plastics and also the uses of these plastics. Let's start our theory session here. Plastics are important class of synthetic material. Like synthetic fibers, plastics are also polymers. What are polymers? You must be knowing this. Polymers consist of multiple units. This I have already told you. Joined together, right? So the single unit of polymer is called as monomer. Like for example, in cellulose, the glucose units are joined and they form a polymer, right? So poly means many, mer meaning unit. Likewise, a plastic is also a synthetic polymer. That is man-made polymer. It is made in the laboratories. The monomer unit is a chemical. Plastics are part of our everyday life, right? We can't these days we can't survive without plastics. There are many articles or many objects made of plastics which we are using. The arrangement of monomers in plastic can be linear or cross-linked. See, these are the monomers. Say for example in glucose, the cellulose, the monomer units are glucose. These can be, say, the linear or cross-linked. Your monomers, how can they be? Say for example, this is a monomer and these monomers can be linked like this. That is linear arrangement of monomers. They can be cross-linked also. Cross-linked means, see, this is one monomer. This is another monomer. Now this can be linked to the next chain. These can be linked. There can be another layer also. So this type of linking is called as cross-linking. You can see each and every monomer layer or monomer unit in the layer is cross-linked. This is cross-linked and this is the linear. So based on these type of arrangements, the plastics are of two types. One is the thermoplastic and the other is what? The thermosetting plastic. In thermoplastics, the arrangement of monomers is linear, whereas the linking of monomer, it's not the arrangement, it's the linking of monomer is linear. Whereas in thermosetting plastics, the linking of monomer is what? It is cross-linked. Thermoplastic. What type of linking of monomer is there? The monomers are linked in a linear fashion. A thermoplastic, sometimes written as thermoplastics, a thermo with a space and a plastic. Thermo, space and plastic, is a type of plastic made from polymer resins that become a homogenized liquid when heated and hard when cooled. That is, these plastics are made up of homogenized liquid, which, say, a substance, a polymer resin, which when heated forms a homogenized liquid and when cooled it becomes hard. Thermoplastics can be reheated, reshaped and frozen repeatedly. This quality makes thermoplastics recyclable. So these are the plastic glasses. This you must have seen. These are the glasses of polystyrene, of which styrene is a compound, right? Styrene is a monomer and it is a chemical compound, right? Now these styrene units, they link. If I'm drawing the structure of styrene, I don't think I should draw it here. You just remember it's a chemical compound. It will create confusion in your mind. So I'm not drawing the structure. The styrene monomers are linked in a linear manner and they form what? They form thermoplast, this polystyrene. And that can be molded into these classes. Now this is recyclable. That is, when it is heated, it will melt again. It will melt and can be given different shapes. So these can be reheated, reshaped and frozen repeatedly. That is why they are used. See, these are plastic bottles which we normally use at home, right? These are also all made up of plastics. The high density polythene or low density polythene is used for it, or even polypropylene is used. Polypropylene. Polypropylene, it is normally written as PP, and it is used for making these plastic bottles. Your ketchup bottles, containers, medicine bottles, automobile battery casings, etc. Right? And remember, all the disposable cups, they are made up of polystyrene. These plastics, these bottles, some may be made up of high density polythene, HDPE, or they may be made up of polypropylene. But it's all a kind of plastic. And that too, what kind of plastic? It is a thermoplastic. That is, it is heated, then melted, and then cooled. And it can be molded into any shape. See, these are also plastic things. These are all made up of plastics. What are the other kind of plastics? I'll tell you the number of, I'll tell you a few types of plastics. But these are all plastic materials which we are using these days. PVC, polyvinyl chloride. It is another, quality of a plastic. It is also a plastic. It is made up of the monomer. Here, see, it is polyvinyl chloride. The monomer unit here is vinyl chloride. So many vinyl chloride units, they join or they combine in a linear manner and they form what? Polyvinyl chloride. It is used for making pipes or sanitary fittings, such as these are all the sanitary fittings. The pipes, they are all made up of polyvinyl chloride. One of the example of plastics is low density polyethylene. As the word suggests, polyethylene. It means the monomer unit here is ethylene. The single unit is ethylene. That is, ethylene units are linked, forming polyethylene. And it is low density polyethylene. This polyethylene is the most commonly encountered thermoplastic and is used for making polybags, grocery bags, and packing of foods and bread. See, these are made up of low density polyethylene. Right? There is one more type of polyethylene, that is high density polyethylene. Let's see what is it. High density polyethylene. The difference here is of the process or of the conditions under which polymerization is taking place. What is polymerization? See, the monomer units are there. Ethylene, the monomer unit is ethylene here and it is CH2CH2. Now these ethylene units are to be linked. They can be linked under different conditions. So HDPE and LDPE both are the polymers of ethylene only, but the conditions under which they are made is different. So high density polyethylene is a higher grade plastic. It is also a thermosetting plastic. That is, when it is heated, it melts, and on cooling it sets. And it can be reheated, remolded like that. So high density polyethylene is used for making containers for strong and corrosive household materials, like say Harpic is there, the bottle of Harpic. Harpic acid contains acid in it. So strong and corrosive households are kept in high density polyethylene containers, and the industrial chemicals such as bleaches and acids. Do remember, the low density polyethylene LDPE is used for making polybags. The thinner is the polybag, the lower is the quality. And high density polyethylene, it is used for making thick containers which are resistant to chemicals, which are resistant to bleaches or acids. And what is the difference between the high density and low density polyethylene? It's just the conditions under which polymerization is taking place. Polymerization is what? It is linking of monomer units. So HDPE and LDPE differ in the conditions under which the polymerization of ethylene is taking place. There is one more example of plastic, that is PET, polyethylene terephthalate. So what will be the monomer here? Monomer will be ethylene terephthalate. This is also one of the chemical compound. It is obtained from it is a petroleum byproduct, or it can be obtained from petroleum. It is used for making containers for microwave cooking. See, you must have seen microwave safe containers. They are thick and they do not melt when microwaves fall in it, or they do not melt in microwaves. But they can't be used over a gas stove. Likewise, bottles of carbonated beverages, right? What are carbonated beverages? Examples like Coke is one of the carbonated beverage. Coca-Cola is one of the carbonated beverage. So the bottles of these carbonated beverages are made up of PET, that is polyethylene terephthalate, and other food containers, the ones which are thick, right? So do remember the plastic container in which the strong and corrosive households can be kept is made up of HDPE. Whereas the ones which are microwave safe, they are made up of PET. Another example is PP, that is polypropylene. Here the monomer unit is propylene. Right? I'm writing the formula, but this is not in your syllabus, so don't do it. These are the monomer units. They link and they form PP, that is polypropylene. It is used for making ketchup bottles, yogurt containers, medicine bottles, and automobile battery casings. These are all what? These are all thermoplastics. These, when heated, they are in the liquid form. When it is freezed, they become solid. Right? They can be reheated and remolded. There is one more category of plastic, that is PVC. I have already told you about this. PVC is what? It is polyvinyl chloride. So these are all the examples of thermoplastics. Now let's see about the thermosetting plastics. What is the difference between the thermoplastic and thermosetting plastic? Thermosetting plastics. Thermoset or thermosetting plastics are synthetic materials that strengthen on being heated and can be molded. They say when it is heated, it gets strengthened. Say it is kept in a mold and it is heated. So it is strengthened on being heated. It should be like this. But cannot be successfully remolded on reheating. On heating, the monomers get cross-linked and become hard. What are thermosetting plastics? They get cross-linked on being heated. Say it is one. This is a linear chain of monomers. Another linear chain of monomers is there. Now when this will be heated, these monomers will get cross-linked. Now once they are cross-linked, they will become hard. Right? Normally what thermoplastics, what is the thing? When they are heated, when a thermoplastic is heated, it comes in a liquid state. And when the temperature is lowered, when it is frozen, it becomes hard. But in thermosetting plastics, when these plastics when they are heated, they get cross-linked and they become very, very hard. Second thing, that once these cross-links are formed, once this plastic has become hard or plastic is hardened, it cannot be reheated and remolded. This is the difference between these two types of plastics. So this is in contrast to thermoplastics, which soften when heated and harden and strengthen after cooling. So thermoplastics, they soften when heated and hardened and strengthened on cooling. Right? But thermosetting plastics, they when heated, they become strong. They get strengthened. Secondly, thermoplastics can be reheated and remolded, whereas thermosetting plastics, they cannot be remolded on reheating. One of the example of thermosetting plastic is Bakelite. It is a polymer of phenol and formaldehyde. It is normally called as phenol formaldehyde polymer. It is also called as phenol. It is a compound which can be obtained from petroleum. Phenol formaldehyde polymer. It's just for your knowledge, that's it. That is phenol and formaldehyde units, they link and they form this polymer. And it is a thermosetting plastic. That is, once this plastic is heated, the crosslinks will be formed and it will get hardened. So Bakelite is a poor conductor of heat and electricity, and it is very hard, It is used for making electrical switches, handles of various utensils. As it is a poor conductor of heat and electricity, it can be used for making handles of utensils. But it's not a thing that you can just put that handle over the flame of gas. No, you can't heat it. It will get melted again, but it cannot be remolded. I'll show you the things made of Bakelite. See, these are made up of Bakelite. This is fuse, electric fuse. In previous days, or say many years back, the fuses were made up of ceramic. But later, they were made up of plastic, that is Bakelite. This telephone, this was used some, say, 25 years back. Somewhere you can find this phone now also. So, today also. This is also made up of Bakelite. This is an antique piece these days. This switch, this is made up of Bakelite. It is hard. You can feel it. This handle of this kettle is made up of Bakelite, right? So these hard plastics, they are made up of Bakelite. And Bakelite is what? It is a thermosetting plastic. That is, when heated, this plastic forms the crosslinks and it becomes very, very hard. It cannot be reheated and it cannot be remolded, like thermoplastics. Okay. There is another example of thermosetting plastic, that is melamine. This is also a thermosetting plastic. This is an unbreakable thing which you must be having at your home. Unbreakable cutlery which you will be having at your home, made of plastic. It is a versatile material. It resists fire. Do remember this. And it resists fire. It doesn't mean that you can just take that unbreakable plate and heat it over the gas. You can't do that, right? Because the pure fine quality melamine is not available. It is very, very costly, and that resists fire. It can tolerate heat better than other plastics. It can tolerate, right? It doesn't mean that you take your Maggi or anything else and just heat it over the flame. Keep it in this melamine container, take it to the gas and just switch on the flame. No, don't do that, right? A part of it will melt and it is cancerous if it melts and if it is ingested, right? It is used for making floor tiles, kitchenware and fabrics which resist fire. So these are all, see, the quality differs. Melamine objects are there, but their quality is different. These are cutlery. This is made up of melamine. This is made up of melamine. It is unbreakable, it's fine. But you can't just take a hammer and just hit it. You can't do that. So melamine is also one of the thermosetting plastic. That is, when heated, the crosslinks are developed and it becomes hard. It cannot be reheated and remolded. If broken, it's of no use. It can't be recycled. Remember this. Bakelite and melamine can't be recycled. Whereas other plastics, that is your PET, that is polyethylene terephthalate, HDPE, LDPE, polyvinyl chloride, polypropylene, polystyrene, they all can be recycled, right? They can be reheated and recycled. So these plastics, when they are heated, they melt. They come in the liquid state and set on cooling. Whereas thermosetting plastics or melamine or Bakelite, when heated, crosslinks are formed and they become very, very hard. They cannot be remolded on reheating. Thank you for listening patiently, students.